Welcome to another fabulous edition of Comet Algebra. This video is for Algebra 2, Chapter 5, Section 8, Solutions to Quadratic Equations. So we're going to start this video with just a little review from earlier in the chapter. We're going to be asked to solve these two quadratics. So here, in the first example, when we don't have an x term, we know that we can use the method where we take the square root of both sides. So first we need to isolate the x squared by dividing 3 on both sides. And so I get x squared equals 18. And then we take the square root of both sides. So we get x equals plus minus square root of 18. And we know we need to reduce or simplify the radical. It is 9 times 2 is 18. So this becomes plus minus 3 square root 2. Those are the two answers. Here we learned we could use quadratic formula, but that's always my last choice because I find it one of the more difficult methods. I want to factor it if possible, and it looks like these do have a GCF. So we could take out a 4 and an x from both of these terms, and we're left with x minus 3. Therefore, if 4x equals 0, the first answer, x is 0. And if x minus 3 equals 0, x is 3. So hopefully those types of solving are fresh in your mind. And I want to kind of point out that we get different kind of answers. Here, on this example, we got two rational numbers. This quadratic gave us two rational answers. This quadratic, however, gave us two irrational answers. The square root of 2 is irrational. And so that's the focus of this section. We're going to be discussing what type of answers quadratics give us and how we can tell what kind of answers we're going to get. First, we need to define a term here. The term is discriminant. Simply put, the discriminant is the part of the quadratic formula that is under the radical sign. So the discriminant is this, b squared minus 4ac. We just pull out that small part because what happens under that radical determines how many and what kind of answers we get. So let's discuss this discriminant. If the discriminant turns out to be positive and it's a perfect square, you get two rational answers. That's like the example we just had up here. This one gave us two rational answers, the 0 and the 3. So if we would look at the discriminant of this one, it would be a positive perfect square. And we'll do that in just a moment. We'll look at all the different types. If the discriminant is positive, but it's not a perfect square, we're going to have a square root in our answer. Therefore, we're going to have two irrational answers. If the discriminant turns out to equal 0, that is, we have the square root of 0, then the plus minus isn't going to give us two answers at all. So if the discriminant is 0, we just have one rational answer. And we've already done in previous sections, if the square root under the square root turns out to be negative, you have I in your answer, and you get a pair of complex conjugates. So it's a pair of complex numbers. So those are the four different possibilities. We could end up with two rationals, two irrationals, one rational, or two imaginaries. You can call them complex or imaginaries. So now we need to look at the discriminant and be able to state how many and what type of answers we're going to get. So the directions to our example say, determine the number and nature of solutions, but we don't need to solve it. So our answers are going to be something like, and there's the bell. Our answers will be something like two imaginary answers or two irrational answers. We're going to look at the discriminant and just to determine how many answers there are, it'll be 2 or 1, and what their nature is, whether they're rational, irrational, or imaginary. So we just need to look at the discriminant, which is b squared minus 4ac. So you need to find that for each of these. So of course they have to be in standard form in order to pull out the a, b, and c. A is 3, b is 5, c is 8. So let's look at b squared is 25 minus 4 times 3 times 8. And if we multiply this out, if I did this right, I got a negative 71. So that tells us we're going to have a negative under the radical. There is going to be i's in our answer. Therefore, we are going to have two answers, and they are going to be complex. There's two imaginaries is another way to say that. So two complex solutions. We didn't have to solve it. We only needed to look at the discriminant to find that out. So number 12, example 2 rather. Let's put this in standard form. Negative 9x squared plus 12x minus 4 equals 0. Therefore, a is negative 9, b is 12, and c is negative 4. So the discriminant becomes b squared, which is 144, minus 4 times negative 9 times negative 4. And if you multiply this out, we get 144 minus 144. Therefore, the discriminant is 0. And when the discriminant is 0, we only have one solution, and it is rational. So I'm just going to write one rational solution. In example 3, once again, it's not in standard form, so we'll do that first by bringing the 8 over. And then a is 7, b is 2, and c is negative 8. So looking at the discriminant, b squared is 4 minus 4ac, 4 times 7 times negative 8. So we end up with 4 plus 224 is 228, which is positive, but it's not a perfect square. So if it were a perfect square, we would say that we have two rational answers. But since 228 is not a perfect square, we need to say that we have two irrational solutions, because you are going to have a square root in your answer. All right, now we need to do some backwards problems where you're given the answers and you have to go backwards and find the quadratic that they came from or that goes with them. So this is going to take a little practice. Here, 2/3 is given to us as the only solution. And so we need to have some knowledge here. The knowledge we know, we are finding a quadratic. A quadratic has two answers. So if 2/3 is the only solution, we know that it had to be twice, that you have to use that answer twice. So we need to set up, these are the answers. We need to set up the factors. And the factors for 2/3 would be x minus 2/3 and x minus 2/3. Now, and then if we FOIL these, we'll get the quadratic. I do not like working with fractions. Some of you do. You can go ahead and FOIL this if you want to. However, I'm going to look at this x minus 2/3, set it equal to 0, and I'm going to solve for x. I'm going to get rid of this fraction. So first I'm going to add a 2/3 to both sides. No, that's not what I want to do. I want to multiply everything by 3 and get rid of the fraction. Sorry. So I'm going to multiply this by 3, and this by 3, and this by 3. So then I get 3x, 3 divided by 3 is 1, 3x minus 2 equals 0. And then I'm going to add a 2. No, I'm not. This is the factor. Sorry. So 3x minus 2 is the factor that gives us the answer of 2/3. So you can FOIL this and then get rid of the fractions at the end, which is fine because the quadratic doesn't have fractions in it. Or you can multiply 3x minus 2 times 3x minus 2 and FOIL that. Either way, we're going to get to the same thing. Your choice. So foiling this, we get 9x squared. We have minus 6x for the outer product, minus 6x for the inner product, and plus 4 for the last. So the quadratic, if we combine those middle terms, we have 9x squared minus 12x plus 4. In this example, we're also asked to find the quadratic that would give you these two answers. Now, instead of making factors out of these and trying to FOIL, we do know that if we were just looking at this and we were to square both sides, we would get an x squared. But you don't want to square both sides until you have isolated this square root symbol. So this is just another method for going backwards and finding the quadratic. So first of all, isolate this square root symbol by subtracting a 5 from both sides. 2i square root 7. So now that we have this isolated, I can go ahead and put this in parentheses, and I can square this side, and then we're going to square this whole mess. So we're going to FOIL the left side of this equation to get x squared, negative 5x and negative 5x is negative 10x, and then plus 25. And now when we square this left side, the right side, we need to square every single piece. So I don't know if you want to think about squaring the plus and minus sign is really nothing. A positive times a positive is positive, and negative times negative is positive, so this just becomes a plus sign. 2 squared is 4, I squared is just I squared, and square root 7 squared is 7. So we need to simplify this over here. I squared is negative 1, and 4 times 7 is 28, so this becomes negative 28. So to get the quadratic that we need to add a 28 to both sides. And so our final answer is x squared minus 10x plus, I think that's 53, if I added that right. Okay, I had lots of distractions on this video, so sorry about that. All right, that's all you need to do, all the knowledge you need for section 5.8, so have fun with that.